Okay, guys. Last week we have discussed about how the interrupt handled by a CPU. That's the point where we have stopped in the last session related to operating system security. So today we are going to discuss about the storage device hierarchy. Storage storage device hierarchy. So we can consider storage device structure. Right. What is this storage device structure or storage device hierarchy? That means how the storage devices are managed. Okay. How is the arrangement of the storage devices? Okay. When we consider about the storage devices, it consists of several things, several devices. Okay. There are something called registers, something called cache, and the main memory, and also the secondary devices. Okay, so we will consider each of them one by one. First of all, I will draw a certain diagram. By using this diagram, you can understand the storage device hierarchy. Okay, I will take like this way one particular thing, and also this one I will draw bigger in size compared to the previous thing. And again, I'll draw this one. It is pretty much large compared to the previous one. And next one, again, it is larger than the previous thing. And this one, it is also larger than that one. Now, I have considered 1, 2, 3, 4, and 5. And I will take another two things. Okay, this one, 6. Okay, I will take something here, which is less small in size compared to this one. Right. Okay. This thing. Okay. I will write as registers. And this thing. What is this one? This is called as cache. This is called as cache. And this is main memory. Actually, the main memory means our RAM. Main memory. Main memory. And then next thing, it is electronic disk. Electronic disk. Electronic disk. And then you can have something called magnetic disk. Magnetic disk and optical disk. Optical disk and also magnetic tape. Magnetic tape. When you consider here to there, okay, you can see top to bottom. You can see what you can see. You can see the size is increasing. Okay, size is increasing. Okay, what you can observe, size is increasing. Size increases. Size increases from what we call size increases from top to bottom, and in the other way side, size is decreasing. That means the bottom to top size is decreasing. Okay, and the next thing is these are the registers, cache, memory. These things are the memory devices. All of these things are considered as a memory devices, storage devices. It has a memory, certain memory. But what is the fastest memory of all of these things? That is the small size registers. Okay, the registers are having the fastest memory in our computer system. Registers are having fastest memory in our computer system. Okay, after that, what will be the fastest one? That is the cache. Cache memory is the secondly fastest memory. Then our main memory. Main memory means it is the RAM. Okay, normally Main memory means it is the RAM. Okay, RAM. RAM is the third fastest memory. Okay, RAM. Okay. Then the electronic discs and then the magnetic disk. After that, optical disk and the magnetic tape. Okay, these are the basic storage devices which are available in our computer system. Okay. Okay, from top to bottom you can understand the size is increasing. Okay, and if we consider about the other way around, when it goes from bottom to top, you can say what you can say, the it will the fast, bottom to top it will be faster. That means the speed increases. Okay, speed increases, speed increases. And uh, what you can say about these things? Well, what will be the what we consider about the cost of these things? What will be the expensive one? If we consider about this register cash, those are more expensive compared to these bottom things. Okay, if you can compare register is more expensive than the cash. Cache is more expensive than the main memory or the RAM. Okay. Then RAM is more expensive than the electronic discs. Okay, you want to understand when you are going to buy these devices, you want to understand this main memory is more expensive than the electronic disk or the magnetic disk. Like that way, you have to understand the cache memory is more expensive than the RAM, and the registers are the most expensive things. Okay, and also you can say uh, from bottom to top, you can say uh, expensive, expensive, expensive. Okay, right. Then, here to there, if you go from top to bottom, you can say the access time. Access time. That means the time to access for this device. Okay, access time. Access time increases when you go from uh, top to bottom. Okay, uh, those are the things you can understand by using this hierarchy. Okay, now I think you got the idea about this these things. Okay, one thing I want to explain about this RAM and this register cache and the main memory. Okay, these three things. Okay, these three things I will put a line here. Okay, uh, I will erase this one and put let me go only erase this bar. This register. What I want to tell here, this these three things we call them as volatile. Volatile. What do you mean by volatile? Volatile means when the power is off. When the power is off, then the content of these registers will be lost. Means when you off the power or when you lost the power, then the content of this register, the cache and the main memory, those will be lost. That means these are having runtime memory. Okay, they do not have a storage memory. Okay, you can't keep that memory longer duration. Okay, when the power is off, the content will be lost. Again, කරන්ට් එක නැති වුණාම මේ වගේ තියෙන මෙමොරි එක නැති වෙලා යනවා. ඒ නිසා අපි ඒකට කියනවා volatile. And these things, okay, electronic disk, magnetic disk, optical disk, and the magnetic tape, we call them as non-volatile. Okay, and also we call them as the secondary memory devices as well. Okay, uh, these are non-volatile. 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 Non-volatile means if the power, even the power get off, still the memory is available. Okay, in the electronic disk, magnetic disk, and the optical disk and the magnetic tape, when the power goes off, still the memory is available. But in registers, cache, and main memory, when the power gets off, you can't. The memory will be lost. Okay, those are the things. Okay, you want to understand. And there is a special type of RAM that is we call as the NVRAM. NVRAM. NVRAM means it is non-volatile RAM. Non-volatile RAM means where it has a special battery pack, has a special battery pack. By using this special battery pack, even the power gets off, the content won't be lost in this NVRAM. That is related to NVRAM. NVRAM is a special type of RAM, but it is non-volatile. But normally RAM is random access memory. It is what? It is volatile. Okay. Right. Now I will erase this drawing. Okay. Then we will understand about what is this main memory. Main memory. What is this main memory? Right, guys. Okay. Main memory means what actually happens in the main memory. Anything that you load into your computer, anything that you load into your computer, okay, gets loads because of this main memory. ඒ කියන්නේ දැන් ඔයාලා මොනවා හරි කම්පියුටර් එක ලෝඩ් කරගන්නවා කියලා කියන්නේ ඔයා ඒකෙන් යම්කිසි වැඩක් කරගන්න. කම්පියුටරේ ස්ටෝර් වෙලා තියෙන මොකක් හරි ඉන්ස්ටෝල් වෙලා තියෙන ඩිවයිස් එකකින් ඔයා වැඩ කරනවා. ඒ කියන්නේ ඒක රන් කරනවා. අන්න අපි ඒකට කියනවා ලෝඩ් කරගන්න. ඒ ලෝඩ් කරගනිද්දී යූස් කරන මෙමොරි එක තමයි අපි කියන්නේ මේන් මෙමොරි කියලා. මේ මේන් මෙමොරිය තමයි අපි කියන්නේ මේ RAM එක කියලා. RAM එක. Random access memory, RAM. Okay. Anything that you load in your computer gets load to this memory. Okay, I will write it down. Anything that you load in your computer gets load to the main memory. Get loads to the main memory. Okay. Normally the things are stored in the secondary memory. ඒ කියන්නේ මේ ඔයාගේ කම්පියුටරේ දේවල් ඉන්ස්ටෝල් වෙලා තියෙන්නේ secondary memory එකේ. දැන් ගන්නකො හිතන්න just as an example, think about the word processor. Just MS Word software is installed in secondary memory in your hard disk. Okay, that is stored in your hard disk. Or normally the softwares are installed in your hard disk. That means it is a secondary memory. Okay, but when you want to open the word processor MS Word, what are you doing? You are double click and opening that one. You are double click and opening. When you double click and opening, that means you are going to run that software. When you are running that software, it gets loaded into the main memory. When you double click and opening means it is running. When you are running, it will get loaded into the main memory. Okay, that means main memory is for execution purposes. Okay, main memory used for execution purpose. Okay, store මේ අපි පාවිච්චි කරන secondary memory එක පාවිච්චි කරන මොකටද install කරලා තියෙනවා. ඒ කියන්නේ store කරලා තියාගෙන තමයි secondary memory එක use කරන්නේ. But this main memory used for the loading purposes. Secondary memory used for the storage or store or install වෙන්නේ කොහෙද? install වෙන්නේ secondary memory එකේ. load වෙන්නේ කොහෙද? main memory. Right? The best example is your MS Word is installed in your secondary memory in your hard disk, but it gets loads into the main memory when you are going to run that part. Okay. Okay. Then you know that some people are telling that if you are having a larger RAM, then your computer will be fast. You have heard that one. වාට තියෙනවා නම් ලොකු RAM එකක්. දැන් අපි හිතුවොත් 4GB RAM එකකට වඩා 8GB RAM තියෙනවා නම් ඔයා fast. ඔයාගේ machine එක fast කියලා අහලා තියෙනවා. So what's the reason for that one? Is that correct or is that wrong? Actually, it is correct. It is true. If you are having a large RAM size, that means your computer system is fast. How do we explain this one? The reason is, okay, if you are having a bigger main memory, you can load multiple things. Okay, if you are having bigger main memory, that means if you are having RAM. RAM is used for the loading purposes. Now you know that RAM is used for the loading purposes. Okay, you can run කරන්න තමයි RAM එක use කරන්නේ. එතකොට ඔයාට එකවර දේවල් කිහිපයක් ඔයාට run කරන්න නම් මේ RAM එකේ size එක වැඩි වෙන්න ඕනේ. If you have a large size of the main memory, then you can run multiple softwares. You can run multiple softwares. එතකොට ඔයාට multiple things run කරන්න ඕන නම් මොකද ඔයා use කරන්න ඕනේ ටිකක් large size එකක් use කරන්න ඕනේ. ඒක I will explain it by a general example. Okay, think that you are having a book cell, large book cell. Okay, and there are plenty of books available in that large book cell. But if you want to read a book from that book cell, what you are doing, you are using your table. Okay, suppose that you are having a small table. Okay, then what you want to do? Then if you want to read a book, you can since you are having a limited space, you can keep only one book. Okay, one book at a time you can keep. Okay, but if you are having a large table, okay, then you can keep several books and you can refer those books. Okay, the main memory is also like that. That book self is referred to the secondary memory, and that table is referred to that one to that main memory. එතකොට දැන් අර මම කියපු book self example එක book self එක හරියට storage secondary memory එක වගේ. ඔයාගේ table එක හරියට main memory එක වගේ. ඔයාට දැන් පොත් කියවනවා කියලා කියන්නේ ඒක execution එකට යනවා. ඒ කියන්නේ load කරගන්නවා වගේ. හරිද? එතකොට ඔයා මොකද කරන්නේ? ඔයා book self එකෙන් පොතක් අරගෙන ඒ පොත කියවනවා. නමුත් ඔයාගේ table එක පොඩි නම් ඔයාට එකවරකට එක පොතක් වගේ තමයි ගන්න. නමුත් ඔයාලට ලොකු ටේබල් එකක් තියෙනවා නම් ඒ ටේබල් එකේ ඔයාලට පොත් කීපයක් තියාගෙන කියවන්න පුළුවන්. එතකොට ඒ වගේ තමයි RAM එක. RAM එක ලොකු වෙලා තියෙද්දි ඔයාලට පුළුවන් multiple දේවල් ඔයාලට execute කරන්න. එතකොට fastly execute. ඔයාලට ගොඩක් දේවල් execute කිරීමේ හැකියාව තියෙනවා. Right? If the RAM is small, you can't execute multiple things, and your execution speed also small. Okay, if you are having a large RAM, then you can execute fast. Okay, again මේ RAM එක ලොකු වෙලා තියෙද්දි RAM එක size එක වැඩි නම් ඔයාලට පුළුවන් multiple things කරන්න. ඒ වගේම ඒක ඉක්මනට execute කිරීමත් හැකියාව දෙන. ඒ කියන්නේ ඔයාගේ speed එක වැඩි. Okay, if you are having large size in RAM, then you can execute fast as well as you can do multiple things. Okay, that is the first thing we have discussed about what we call the storage hierarchy, and also we have discussed about RAM. And also you know that RAM is random access memory, it is volatile, and there is something called NVRAM. Okay, NVRAM means it is non-volatile memory. Okay, it has a special battery pack. Because of that, okay, even the power gets off, the content won't be lost in NVRAM, but in RAM, when the power gets off, the content will be lost.